Welcome back to the AI Value Paradox by Kategos. Today, we're talking about a number that honestly feels fake, $3 trillion. That is the amount of capital hitting AI infrastructure by 2028. To put that in perspective, it's like taking the entire economy of the UK and pouring it into data centers and chips. In this episode, we're deconstructing our latest white paper to answer the big question: are we looking at the next steam engine or the biggest financial bubble in history? We're diving into the death of Moore's Law, the weaponization of compute, and the reality check that 80% of enterprise AI projects are currently failing. The boom is here, so let's take a look at what we can expect.
Okay, let's just start with a number. $3 trillion.
It's a number that's almost impossible to wrap your head around, honestly.
It really is. I was trying to find a good analogy for it this morning, reading through this new Kategos report we're covering.
And what did you land on?
Well, for starters, it's basically the entire gross domestic product of the United Kingdom.
The whole country's output for a year just gone into data centers.
For an entire year. Or think of it this way, it's more than what Apple, the entire company, was worth just a few years back. And that's the amount of capital, hard cash, that's projected to be poured into the physical infrastructure of AI.
And just through 2028, that's the key part. This isn't a 10-year plan.
Right, this is the immediate future. And that really sets up the central tension for this entire deep dive, doesn't it? It's the $3 trillion question.
It is. Are we witnessing the single greatest technological revolution since, I don't know, the steam engine? Or is this the biggest financial bubble in history, structurally waiting to pop?
And it's not just about, cool chatbots or generating images. The report calls it a fault line running under the entire global economy.
That's a perfect metaphor.
Yeah.
It really is. You can build these incredible, beautiful skyscrapers on a fault line. The views are amazing. The real estate is insanely expensive. Everyone's getting rich.
Everyone's making money.
But the geology underneath, the tectonic plates, they don't care about your Q3 earnings report. They don't care about your stock price. If those plates shift, everything you build comes crashing down.
So let's map out that fault line. That's our mission for this deep dive. We have a lot of ground to cover, and I think it's important we lay out the roadmap for everyone listening.
Good idea.
First, we have to deconstruct this AI bubble debate. We'll look at the obvious comparison, the dot-com crash, and see why it is and isn't like 1999. And critically, we have to talk about something called the death of Moore's Law, which is what's forcing all this spending.
Right. The physics behind the finance.
Exactly. Then second, we're going to dive into what might be the scariest part of this whole thing, what the report calls the geopolitical crucible.
The bifurcation. The splitting of the world.
Yeah, the world is literally splitting into two separate, non-communicating tech spheres, a U.S. sphere and a China sphere. And we'll get into how compute power itself is being weaponized.
After that, we have to ground this in reality.
The commercial reality, as the report puts it. Because, spoiler alert for everyone listening, for all the trillions being spent, the current failure rate for enterprise AI projects is a shocking 80%.
80. It's a number that should be giving every CFO nightmares.
It really should. And then finally, we'll wrap up by looking at the sort of external headwinds, the things that could derail this whole train, like regulations, antitrust, and the simple physical lack of energy and water.
So to synthesize it, the core conclusion here is really nuanced. The AI revolution is very real. It's anchored in physical assets, chips, power plants, data centers. You can touch it.
It's not just code.
It's not just code. But it is surrounded by what you could call a speculative froth, or maybe even a very targeted bubble in certain areas. It's a very strange beast.
Okay, so let's start at the beginning then. The structure of the boom, revolution or bubble. I feel like every time a tech stock so much as blinks, you have a dozen pundits on TV screaming, "It's 1999 all over again. This is pets.com."
The PTSD is real. I get it. If you lived through that crash, you remember the sheer euphoria. You remember companies literally just adding .com to their name and watching their stock triple overnight for no reason.
It was pure mania.
It was. But if you actually look under the hood, if you look at the structure of the capital flowing through the system, 2025 is a completely different animal than 1999. The comparison is, frankly, lazy.
Okay, so break that down. Why is it lazy? It feels similar on the surface.
It feels similar, but the plumbing is different. It all comes down to a simple question. Where is the money coming from? Think back to 1999. Who was funding that boom?
Venture capitalists, right.
Yeah.
Speculative money.
Speculative VCs, junk bonds, and a flood of initial public offerings, IPOs, for companies that had zero revenue. Zero. It was hope capital. The entire business model was, and this is a real phrase people used, we lose money on every customer, but we'll make it up in volume.
Right, the infamous eyeballs metric. We don't have profits, but look how many people visited our website. It was completely intangible.
Utterly intangible. And the whole thing was fueled by debt and external fickle capital. The moment the market got nervous, that capital vanished overnight. Poof. It was gone.
Okay, so that was then. Contrast that with today. Who's funding the AI build-out?
It's not a bunch of scrappy startups with a .ai domain. It's the Magnificent Seven. It's Microsoft, Google, Amazon, Meta. These are companies sitting on, and this is not an exaggeration, oceans of cash.
Like, aren't going to VCs with a pitch deck.
They are the VCs. They aren't borrowing money from grandma or issuing junk bonds to build these data centers. They are using their own free cash flow. These are the most profitable cash-generating entities in the history of capitalism.
And that is a massive, massive distinction. In 1999, if the NASDAQ dropped 10%, the funding window slammed shut. The money was external.
Gone.
Today, Microsoft can announce an $80 billion CapEx plan for AI and still have enough left over to pay a dividend and buy back stock. They are self-funding the revolution from their own profits.
Which makes this boom, or bubble if you want to call it that, much harder to pop. It's made of titanium, not soap. But there's another structural difference that I think is even more important, and that's the nature of the actual asset being built.
What do you mean?
In the dot-com boom, what did we build? We built infrastructure, specifically fiber optic cables. We laid millions and millions of miles of dark fiber under the oceans and across every continent.
And we built way, way too much of it. I remember the stories about companies going bankrupt because they had all this capacity and no one to sell it to.
A massive supply glut. It took a full decade, almost to 2010, for internet traffic to actually grow enough to fill the capacity we built in the year 2000.
Yeah.
It absolutely crushed the telecom industry for years.
So there was too much supply, not enough demand.
Exactly. Now, fast forward to today. In AI, we have the precise mirror image opposite problem. We do not have a supply glut. We have a supply famine.
We can't make the chips fast enough.
We can't make the chips fast enough. We can't build the data centers fast enough. We can't find enough energy to power them or enough water to cool them. The demand for what the report calls compute utility, and I love that phrase, utility, is outstripping supply by an order of magnitude.
It's a utility. That's a great way to think about it. When you rent time on an NVIDIA H100 GPU in the cloud, you're not buying eyeballs.
No. You're renting a machine that does work. It's as tangible as renting a bulldozer or a crane. It performs a service with a measurable output. It's a real asset.
Okay, so let me just recap. We have highly profitable, cash-rich companies funding the creation of a tangible, utility-like asset that is currently in a state of extreme undersupply.
That's the bull case in a nutshell.
So why are we even having a bubble conversation? That sounds like the most stable investment thesis I've ever heard. Where's the risk?
Oh. The risk is that the cost of staying in the game is escalating geometrically. It's an exponential curve that is bending straight up. And this links directly back to your earlier point about Moore's Law.
Right, the old rule of thumb for the entire tech industry for 50 years.
It was more than a rule of thumb. It was the engine of progress. It was a free lunch. Gordon Moore observed that every 2 years or so, the number of transistors you could fit on a chip would double.
Which meant chips got twice as fast, but also cheaper.
And smaller, and more power efficient. You didn't have to be a genius to have a growing tech business. You just had to wait for Intel to release the next generation Pentium chip, and your software would magically run twice as fast.
And the Kategos report was pretty blunt on this. They basically said Moore's Law is dead.
It's effectively dead. Or at least the economic part of it is. We've hit the fundamental limits of physics. You can't just shrink transistors much more before they start melting, or you run into bizarre quantum tunneling effects where electrons just teleport out of the wire.
So the free lunch is over.
The free lunch is over. So the industry had to pivot. And we pivoted to what some people are now calling Huang's Law, named, of course, after Jensen Huang, the CEO of NVIDIA.
And that law is essentially, if you can't make the chip smaller and more efficient, you just have to make the whole system bigger and more specialized.
Exactly. We've moved away from general-purpose CPUs, the Swiss Army knives of computing, to these highly specialized accelerators, primarily GPUs. These things are massive, parallel processing monsters that are designed to do one thing and one thing only, incredibly well. matrix multiplication.
Which is the core math behind all of AI.
The core math. But here's the catch. The performance gains you get from this new approach are no longer free. They come at a staggering cost in terms of money, physical size, energy consumption, and heat generation.
The numbers in the report on this were just mind-blowing to me. They tracked the amount of compute needed to train the biggest AI models over time.
And the curve is terrifying. The training compute requirements have been growing 750 times every 2 years, not doubling, 750x.
750 times, that's not a curve, that's a wall.
It's a vertical wall. Let's
Yeah.
make it concrete. Think about the transition we just went through as a society. For years, we had perception AI. That's software that could look at a photo and correctly identify that's a cat.
Right. Image recognition.
Then in the last couple of years, we made the leap to generative AI. Now the software can't just identify the cat. It can paint you a brand new picture of a cat in the style of Van Gogh, or write a poem about the cat.
A much more complex task.
A vastly more complex task. And that leap from perception to generation required a 1,000 times increase in compute power. 1,000x.
And now the race is on for the next big thing, which everyone is calling agentic AI.
Right, AI that doesn't just generate content but takes action in the real world. It reasons, it plans a multi-stop travel itinerary for you, it books the flights and hotels, and when a flight is canceled, it automatically rebooks you.
That feels like the holy grail.
It is. But that jump from generative to agentic, the report estimates will require another 30 to 100 times increase in compute on top of the previous 1,000-fold jump.
So you see the trap. It becomes this death spiral of spending. To get the next breakthrough, you don't just need smarter programmers. You need a dedicated power plant. You need a data center the size of a small city.
You've just transformed software development, which for decades was a beautiful, low-capital, high-margin business, into heavy industry. It's more like building a steel mill or an automotive plant now.
Which, of course, explains why only the giants can play this game. And that brings us right back to the $3 trillion figure and the insane spending spree.
It is an absolute arms race, a game of chicken played with corporate balance sheets. Let's just run through the CapEx, the capital expenditure projections for 2025 alone. These are the official numbers.
These aren't guesses.
Not guesses. Amazon has raised its spending target to around $125 billion.
$125 billion. For context, that's more than the entire GDP of, say, Hungary or Morocco in 1 year from one company.
From one company. Google, or Alphabet, is targeting around $85 billion. Microsoft is around $80 billion. Meta is in the $70 billion range.
It's just the scale is hard to process, and the report's argument is that this isn't even offensive spending, it's defensive.
It's 100% a defensive moat. Think about it from Google's perspective. For 20 years, they've had a monopoly on search. Now, all of a sudden, Microsoft integrates a truly useful AI into Bing, and OpenAI is a threat. If Google hesitates, if they stop spending for even 1 or 2 quarters, they risk their entire $2 trillion franchise.
Same for Amazon with AWS. If they don't have the latest and greatest chips, their cloud customers will just go to Microsoft Azure or Google Cloud.
It's mutually assured destruction. They aren't spending this money because they want to. They're spending it because they are absolutely terrified of what happens if they don't. It's an existential threat.
Okay, but this is where the fault line, for me, really starts to show some cracks. We have these massive, almost unbelievable spending numbers. But when you start to peel back the layers and ask, where is this money actually going and where is it coming from, you find something. Well, something really disturbing.
The circularity.
The circularity. This is the concept from the report that I think is the most critical for listeners to understand, because this is the precise mechanism that can turn a healthy, infrastructure-driven boom into a dangerous, self-referential bubble.
I couldn't agree more. It reminds me a lot of something that happened during the dot-com boom, something called vendor financing.
Explain that.
Okay, so back in the late 90s, Cisco Systems was the king. They made all the routers and switches that powered the internet. But to boost their sales, they started doing something clever and dangerous. They would lend money to a hot new .com startup.
Okay.
And then that startup would turn around and use the exact same money they were just loaned to buy a bunch of routers from Cisco.
Oh, wow. So Cisco is essentially paying itself with its own money.
Exactly.
Yeah.
It shows up on the books as legitimate revenue. Cisco's sales go up, their stock price soars, everyone's happy. But no new external cash ever entered the system. It was just Cisco moving money from its left pocket to its right pocket. And when those startups went bust, Cisco was left holding worthless debt.
It created this illusion of massive organic growth when it was really just an echo chamber.
It's the perfect analogy. What we're seeing now is vendor financing 2.0, but on a scale that absolutely dwarfs the 90s. And the company at the center of it all is NVIDIA.
Let's walk through the NVIDIA loop, as the report calls it, because it's a little complex, but it's so important.
Okay, so follow the dollar. At the top of the food chain, you have the chip maker, NVIDIA. They are approaching a $5 trillion market cap. They have a near monopoly on the high-end chips everyone needs.
So everyone buys from them. Who are their biggest customers?
Their biggest customers are the big cloud providers,
Yeah.
Microsoft with Azure, Amazon with AWS, Google Cloud, and also specialized players like CoreWeave.
Okay, so cloud providers buy chips from NVIDIA. Now, who are the cloud providers' biggest customers for all that AI compute?
That would be the AI model builders. The companies actually creating the large language model. So OpenAI, Anthropic, Google's DeepMind, Elon Musk's xAI.
Got it. Chipmaker sells to cloud, cloud sells to model builder. So far, so good. But here's the twist. Who is investing in the model builders?
Well, Microsoft famously invested $10 billion into OpenAI. Amazon invested $4 billion into Anthropic. And NVIDIA itself has a massive venture capital arm investing in dozens of these AI startups.
And there it is. That's the circle.
That's the loop. So let's trace it again. Microsoft gives OpenAI $10 billion in investment capital. What does OpenAI do with that cash? They turn right around and pay it back to Microsoft to rent Azure cloud servers to train their models.
So the money just goes back to Microsoft. It shows up as Azure revenue.
Exactly. Then what does Microsoft do with that cash? They use it to buy more chips from NVIDIA. NVIDIA records massive, record-breaking revenue and profit. Their stock goes through the roof.
And then NVIDIA, flush with cash and a soaring stock price, turns around and invests in more AI startups like CoreWeave,
who then use that investment money to buy more NVIDIA chips. The report details specific deals where NVIDIA's investment is contingent on the startup deploying their hardware. It's a closed, self-reinforcing loop. I give you money, you use that money to buy my product, I book the sale as revenue, my stock goes up, which gives me more money to invest in more companies who will then buy my product.
It creates this powerful illusion of near infinite organic demand. But the actual external cash, the money from, a regular company buying insurance or a consumer buying toothpaste, that money hasn't really shown up in a big way yet to pay for all this.
That's the critical disconnect. The report calls it the valuation reality gap. Right now, the global market for generative AI software and services is sitting at around, let's say, $45 billion.
Which sounds like a lot.
It is a lot. But the market capitalizations of the companies in this loop, NVIDIA, Microsoft, the valuation of OpenAI, they aren't priced for a $45 billion market. They're priced as if that market is guaranteed to hit $1 trillion by 2028.
So we need the actual end-user market to grow by more than 20 times in the next 3 to 4 years just to justify the stock prices we have today.
In a possibly steep slope. And look at the finances of the model builders themselves. OpenAI is projected to do maybe 12 or 13 billion in revenue in 2025. That sounds amazing. Until you read the fine print and see they are running at a $10 billion operating loss because their compute and personnel costs are so astronomical.
They're basically breaking even on a good day.
On a good day. So this whole $3 trillion bet, this whole circular valuation machine, it all relies on one giant assumption.
That eventually, real customers, banks, hospitals, law firms, regular consumers are going to show up with trillions of dollars in new spending to pay for all this compute utility.
And if they don't show up, or they don't show up fast enough,
the music stops. The circularity breaks. If Microsoft's board looks at their Azure numbers and says, hey, wait a minute, we're not seeing the return on investment here, and they cut their CapEx by 20%.
NVIDIA's order book collapses overnight. Their stock tanks. If NVIDIA's stock tanks, the venture capital they were spraying into the ecosystem dries up, the whole thing is leveraged on the assumption of technological perfection and guaranteed mass adoption. If there's a hiccup in either of those, the whole loop shutters.
That is an incredibly precarious foundation to build a $3 trillion industry on. And we've only talked about the financial risks. We haven't even layered on the fact that this entire delicate global supply chain is being systematically ripped in half by geopolitics.
Which brings us to the geopolitical crucible. And you're right, the report reads like a Tom Clancy novel. It's industrial espionage, diplomatic power plays. It's fascinating stuff.
The core premise is that the globalized tech stack we've lived with for 30 years is over. It's dead.
It's completely dead. That old world where a chip was designed in California, manufactured in Taiwan using equipment from the Netherlands, assembled in China and then sold everywhere, that world is gone. We are actively, purposefully splitting into two hard, incompatible spheres, a U.S.-led sphere and a China-led sphere.
And the U.S. strategy seems to be one of pure containment, what the report calls weaponized compute.
That's the perfect term for it.
Yeah.
The U.S. government, across administrations, has woken up to the fact that advanced AI isn't just a commercial product. It's the fundamental building block of future military, economic, and intelligence power.
So they're using access to the best chips, mainly from NVIDIA, as a diplomatic carrot and stick.
Exactly. And the G42 story from the report is the perfect case study. It feels like a real turning point in this new Cold War.
Let's walk through that one because it's so illustrative of the new rules of the game.
Okay, so you have G42. They're this huge state-backed AI holding company based in the United Arab Emirates. They have insane amounts of money, massive ambition, and they want to be a global AI superpower.
And historically, they play both sides, right? Like a lot of countries in the Gulf.
Precisely. They were buying the best tech from Silicon Valley, but they were also working very closely with Chinese firms like Huawei. They were trying to be neutral, a bridge between East and West.
The classic non-aligned strategy.
And it worked for a while. But then, as the report details, the U.S. Commerce and State Departments essentially walked into their boardroom and delivered an ultimatum. This wasn't a friendly suggestion. It was, you have a choice.
You can be on our team or their team.
You can have access to NVIDIA's next-generation Blackwell chips and Microsoft's Azure AI platform, or you can keep your Huawei gear and your Chinese business partners. You cannot have both. Pick one, now.
And the choice they made was pretty immediate.
They folded instantly. They publicly announced they were stripping out all Chinese hardware, divesting from Chinese tech funds, and cutting all operational ties. They even agreed to let U.S. intelligence agencies audit their systems to ensure compliance.
And their reward for this loyalty.
A $1.5 billion investment from Microsoft. It's transactional. We are creating what is essentially a compute NATO. You are either inside our secure U.S.-controlled technology alliance, or you are outside in the cold, cut off from the best hardware.
So that's the U.S. containment strategy. How is China responding to this? Because there is no way Beijing is just shrugging its shoulders and saying, oh, well, I guess we won't be an AI superpower.
Oh, quite the opposite. This intense U.S. pressure has triggered a fierce nationalistic backlash. The report calls it the domestic mandate. China has shifted its entire strategy away from trying to acquire or reverse engineer Western tech to one of total, absolute self-sufficiency. It's a delete America campaign from their tech stack.
The report mentioned a specific government directive ordering state-funded projects to use exclusively domestic Chinese chips.
Yes, directives like Document 79. This is a state order. They're literally going into unfinished data center projects and ripping out Western hardware. Even if they have the legal, compliant, watered-down NVIDIA chips that are allowed for export.
CH20s, I think they're called.
Right. They're pulling those out and replacing them with homegrown chips from companies like Huawei, the Ascend 910 series. It's a matter of national security and technological sovereignty for them now.
But I thought the whole point of the U.S. export ban was that China can't make chips that are as good. Aren't their domestic chips just worse?
They're worse, yes. On a pure performance per watt basis, an Ascend chip is maybe 60, perhaps 70% as efficient as a top-tier NVIDIA chip. But this is where it gets really interesting. China has a secret weapon in this fight that changes the economic calculation completely.
And that is the energy moat.
The energy moat. This was one of the most fascinating parts of the report for me. Okay, so think about it. If your chip is less efficient, what does that mean in practical terms?
It means it uses more electricity to do the same amount of work, and it produces more waste heat.
Exactly. In the West, especially the U.S. and Europe, electricity is expensive, and grid capacity is severely constrained. So that inefficiency is a huge cost penalty.
But not in China.
Not in China. China has spent the last 2 decades building out the world's most massive renewable energy infrastructure. They build something like 2/3 of all new global wind and solar capacity every year. They have these incredible ultra-high voltage power lines that can move massive amounts of cheap green electricity from the sunny, windy west of the country to the big industrial data centers in the east.
So they have a surplus of cheap state-controlled power.
An enormous surplus.
Sure.
And the government is weaponizing it. They are offering huge energy subsidies, the report says up to 50% off the electricity bill, for any data center that agrees to use domestic Chinese chips.
Wow. So they're using their energy advantage to offset their silicon disadvantage.
It's brilliant asymmetric economic warfare. Think about the total cost of ownership calculation for a data center operator. Okay, my Huawei chip is 30% slower. But if my single biggest operating cost, my electricity bill, is cut in half, I might actually come out ahead. My cost per calculation might be lower than the guy in Virginia paying market rates to power his NVIDIA rig.
That is fascinating. So the end result here is not that China gets shut out of AI.
Not at all. The end result is that China will have a massive, thriving, state-of-the-art AI ecosystem. It would just be completely and utterly incompatible with ours. It will be built on different hardware, running different software standards, trained on different data sets, and aligned with different political values. Two parallel universes with no contact.
And this bifurcation, this split, it worries me for another reason that the report touches on, which is the talent war and the future of scientific progress itself.
The human element.
Yeah. For decades, we've benefited from this incredible global brain trust. A researcher in Beijing publishes a breakthrough paper on a new algorithm. A researcher in Boston reads it that night, builds on it, and publishes an improvement a month later. That cross-pollination is what drives science forward.
And that is being systematically severed. We're seeing it with visa restrictions on students and researchers. We're seeing academic collaborations being shut down over national security concerns. The free flow of ideas is being choked off.
And we're seeing talent migrate. The report notes a big flow of European AI talent moving to the U.S. simply because that's where the big models and the big computers are.
Which is great for Silicon Valley, but it's a disaster for Europe's long-term competitiveness. But the real swing state, the country everyone is watching in this talent war, is India.
India is the new talent factory.
It's the primary global source. The report had a crazy statistic. Something like 28% of the entire AI workforce in a major hub like Dublin, Ireland, actually got their degrees in India. The U.S. is desperately trying to pull India into its orbit, strengthening academic and commercial ties, because that pipeline of human capital is a massive strategic advantage.
And the risk here isn't just about which country wins. The risk is that we all lose.
That's the real tragedy. If we fracture the global scientific community, we might still get breakthroughs, but we'll get them slower. We delay the cure for cancer. We delay new materials for climate solutions. We might end up with a very smart American AI and a very smart Chinese AI, but neither one will be as smart as the global AI we could have built together.
It's a global-scale tragedy of the commons, played out with silicon chips. Okay. So, we've established the financial bubble risk with the circularity, and now the profound geopolitical fracture. But let's bring this down from the stratosphere and look at what's happening on the ground inside actual companies.
The commercial reality.
Because if I'm a CEO of a Fortune 500 company, I'm hearing about this $3 trillion spending spree, and all I'm thinking is I'm falling behind and need to get on board. But this section of the Kategos report is a giant bucket of ice water.
It's a very grim picture. The headline statistic is just undeniable, and it's been corroborated by multiple studies. The failure rate for enterprise AI implementation projects is currently hovering around 80%.
80%. That is a catastrophic number. Let's put that in perspective. If an airline had an 80% failure rate, planes would be falling out of the sky every hour. If a construction company had that failure rate, our cities would be rubble. How is it possible that it's so high for AI?
Because companies are making a fundamental category error. They are treating AI like it's a software upgrade, like installing the new version of Microsoft Office. But it's not. It's a culture transplant. They are buying a Formula One race car, parking it in a muddy field, and then they're mystified when it can't go 200 miles an hour.
Give me a concrete example. What does a failed project look like in the real world?
Okay, let's take a hypothetical. A big traditional bank. The CEO reads an article about ChatGPT and sends down a memo. We need to cut costs in the call center, build an AI customer service agent, make it happen.
Sounds like a pretty standard use case.
It's the #1 use case everyone tries first. So they go out, they spend $10 million licensing a model from a big vendor, they hire a fancy consulting firm to hook it all up, and they deploy a chatbot on their website.
And then what happens?
Disaster. First, they never bothered to clean up or unify their underlying customer data, which is a mess of siloed 30-year-old legacy systems. So the bot is training on garbage data. It starts hallucinating, confidently making things up. It tells a customer they qualify for a mortgage they don't. It offers a refund for a product the bank doesn't even sell.
I remember reading about the Air Canada case where their chatbot literally invented a bereavement fare policy that didn't exist, and a court forced the airline to honor it.
That is the canonical example. So the legal and compliance departments see this and have a collective heart attack. They shut the whole project down. Or, alternatively, the call center employees were never trained on how to work with the new tool. They see it as a threat or as a nuisance, so they just tell customers to ignore the bot and call them directly, completely bypassing the new system.
So the project is eventually scrapped, the $10 million gets written off as an innovation expense, and the CEO concludes, "See, I told you AI was just hype."
And that is the impact gap, in a nutshell. The technology itself actually worked. The LLM could understand language and generate text, but the business impact was zero, or even negative, because the foundational pieces, the data, the process, the governance, and most importantly, the people, weren't ready for it.
It's the human element again. You can't just code a new corporate culture.
You can't. And the report highlights the top reasons for this 80% failure rate. Number one is a lack of deep in-house technical talent. Companies are completely reliant on expensive outside vendors because they don't have engineers who truly understand how these models work under the hood.
They're just buying a black box.
A very expensive black box.
Yeah.
Number two is unclear use cases. They're what we call solutions in search of a problem. And the biggest one of all is what you said, workforce inertia and a failure to transform how people actually do their jobs.
And this problem is about to get way worse, isn't it? As we move towards this agentic AI we talked about earlier.
It's an order of magnitude harder. It's one thing to let an AI summarize a document for you. It's another thing entirely to let an autonomous AI agent file your corporate taxes, or design a clinical drug trial, or execute trades on the stock market.
No way. The legal and regulatory risk is just off the charts. Who do you sue when the AI agent commits fraud?
Exactly. So what we're seeing is a phenomenon the report calls pilot purgatory. Companies are running hundreds of small-scale pilot projects. They look great in a PowerPoint presentation to the board, but they are too terrified to deploy them at scale in the real world because they don't have a governance safety net.
So the spending on pilots and infrastructure continues. They keep buying the chips from NVIDIA and the cloud services from Microsoft. But the promised productivity gains never actually show up on the company's profit and loss statement.
And if those productivity gains don't materialize across the economy, then the corporate revenue to pay for all this AI utility never materializes. Which brings us right back to our circular loop problem. It's the commercial failure on the ground that could be the pin that pricks the financial bubble at the top.
It's all connected. Okay, we have one last major section to cover before we wrap up with some takeaways, and these are the big external headwinds. These are the forces that could slow this whole train down, no matter how good the tech is or how much money is being spent.
But the laws of physics and the laws of man.
Exactly. We talked about the energy moat in China, but globally, the report argues we are hitting a hard energy wall.
We are. The physical reality of AI is finally catching up to the digital marketing hype. AI doesn't live in a metaphorical cloud. It lives in a very real, very hot building full of racks of servers that consume astonishing amounts of electricity.
And the growth in that demand is outpacing the grid's ability to supply it.
By a lot. Data center power demand is growing globally between 20 and 30% per year. Our electrical grids were not designed for that kind of load growth. They were designed for maybe 1 or 2% annual growth.
I've seen the stories coming out of places like Northern Virginia, which is the data center capital of the world. They're basically in a state of emergency. Utility companies are telling new data center projects, we physically cannot connect you, come back in 2028 maybe.
It's happening there. It's happening in Dublin, in Amsterdam, in Singapore. These are the major internet hubs. And local and national governments are starting to put moratoriums in place. They're just denying the permits to build. Access to a power plug is now a critical business continuity risk. If you can't plug your $3 billion data center in, it's the world's most expensive paperweight.
And it's not just power. The report points out it's also water.
A massive, underappreciated constraint. These facilities use millions of gallons of water a day for cooling through evaporative cooling towers. Trying to build a giant data center in a drought-stricken area like Arizona or Nevada is becoming a major political flashpoint.
So we have the physical constraints, and then, as you said, we have the laws of man. The antitrust hammer is starting to swing.
The regulators are finally waking up, and they are not happy. The FTC in the U.S., the Department of Justice, the EU's Competition Commission, they're all starting to look at the concentration of power in this market, and they're using language we haven't heard since the trust-busting era.
They're talking about compute as an essential facility. What does that mean?
It's a legal doctrine that says if you have monopoly control over a piece of infrastructure that is essential for participating in the economy, like the railroads in the 19th century or the phone lines in the 20th, then you can be regulated like a public utility. The argument is that if a handful of companies, Microsoft, Google, OpenAI, control the bottleneck to intelligence itself, they effectively control the entire future economy.
And we're already seeing lawsuits. The report mentions the class action suit against Microsoft and OpenAI.
Yeah, alleging that their exclusive partnership was designed to create artificial scarcity of GPUs and advanced models in order to drive up prices and lock out competitors.
Yeah.
Whether it succeeds or not, it's a sign of things to come.
There's another fascinating legal concept in the report, algorithmic collusion. This sounded like something out of science fiction.
And one of the most intellectually interesting and terrifying risks out there.
Yeah.
The idea is this. What happens when all the companies in a given industry, let's say all the major airlines, start using the same AI-powered pricing agent to set their ticket prices?
Oh, okay.
Those algorithms might, all on their own, learn over time that the optimal strategy is not to compete on price. They might learn that if I raise my prices by $5 and my competitors' algorithms see that and also raise their prices by $5, we all make more money. It's collusion. It's price fixing. But no humans ever got in a room and made a secret deal.
It's a silent, spontaneous conspiracy of machines.
How do you prosecute that? Your Honor, my algorithm developed a collusive consciousness all by itself. It's a legal and regulatory nightmare.
And finally, you have the Brussels effect.
Ah, yes. The EU's AI Act, a massive, comprehensive piece of legislation with extraterritorial reach, meaning if you want to do business in Europe, you have to comply. It's imposing very heavy, very expensive compliance, documentation, and auditing costs on AI developers.
And the irony is?
The irony is that these well-intentioned regulations might actually end up hurting the small European startups they're meant to protect and helping the giant U.S. tech companies. Google and Microsoft can afford to hire 1,000 lawyers and compliance officers to navigate this maze. A 3-person AI startup in Paris cannot.
So in a strange way, regulation could end up entrenching the very monopolies it's trying to fight.
It's a very real and very dangerous unintended consequence.
Wow. We have covered a massive amount of ground here. I mean, from the $3 trillion capital bet to the financial circularity, the geopolitical split, the commercial implementation crisis, and now these physical and legal walls. It's a lot to take in.
It is the most complex, interconnected, and high-stakes technological and economic landscape I've ever analyzed. Nothing else comes close.
So let's try to synthesize all of this. Let's distill it down for everyone listening. What is the so what here? If you've been listening for the last hour, how should you change your thinking or your actions? Let's break it down by persona, as the report does. First, the investor.
Okay, for the investor, the message is clear. You need to look past the hype at the top of the stack, the application layer. Don't place all your bets on the company making the next cute chatbot wrapper. The real durable value right now is in the input suppliers. It's the classic pick and shovel play.
The people who sold the denim and the shovels during the gold rush made more money than most of the miners.
100%. We're talking about power generation companies, specialized data center cooling technology, the firms that make the high bandwidth memory that goes into the chips, the physical real estate itself. The infrastructure build-out is happening full stop, regardless of whether generative AI lives up to the hype next year. The concrete will be poured, the fiber will be laid. That is where the tangible value is being created. And critically, be very, very wary of any company whose revenue growth depends on the circular loop of financing their own customers.
Great advice. Okay, next persona, the business leader. The CEO, the CIO, the person in the trenches trying desperately not to become part of that 80% failure statistic.
The message for them is, stop. Stop doing 50 different pilot projects poorly. Pick 3, maybe 4 high-impact use cases where AI can solve a real specific business problem and go deep. And for the love of God, spend more money, time, and attention on your people than you do on your software licenses. If you don't upskill your workforce, if you don't redesign your business processes, the technology is worthless. You have to bridge that impact gap by focusing on governance, data readiness, and workflow, not just buying the next shiny tool from a vendor.
Focus and culture. It's not a tech problem.
Okay.
Finally, the citizen, the regular person just trying to understand the world we're all about to live in.
For the citizen, the most profound takeaway is this. You need to understand that the open global internet that you grew up with is over. It's gone. We are entering the era of sovereign AI. Your physical location on the planet will increasingly determine what kind of intelligence you have access to. If you live in the US-led sphere, you will use one set of AI tools trained on one set of data reflecting one set of values. If you live in the China-led sphere, you will have a completely different, incompatible set. The digital world is growing hard borders for the first time.
That's a huge shift. It really feels like we're losing something fundamental and important in that transition.
We are, but that is the geological reality of the fault line we're living on.
I want to leave our listeners with one last provocative thought to chew on. We spent this entire deep dive talking about money and chips and watts and geopolitics. We've analyzed this like it's a giant, complicated mechanical problem. But there's a deep central irony here that I just can't shake. We are betting $3 trillion, again, the entire economic output of a major G7 nation, on the central premise that the machine is on a path to become smarter than us, that artificial general intelligence, AGI, is an inevitable destination. But at the exact same time, we are seeing an 80% failure rate in applying even today's relatively simple AI. And why? Because of our very human limitations, our messy bureaucracy, our corporate politics, our fear of change, our simple inability to organize our own data.
We're building a godlike superbrain, but we don't have a functioning nervous system to connect it to the body of our organizations.
That's it, exactly. And if this historic $3 trillion bet fails, if the monetization doesn't show up and this whole thing corrects violently, it won't be because the technology wasn't smart enough. It will be because we, as people and as organizations, weren't smart enough or organized enough to use it. The ultimate fault line isn't in the silicon or in the financial markets. It's in us.
And that would be the most expensive lesson in human history.
Thank you for diving deep with us. Keep your eyes on the ground because it is definitely moving. We'll see you next time.
We've covered a lot of ground today, from the loops of capital inflating stock prices to the cold, hard reality of energy shortages and a fractured global tech stack. But the real takeaway here, it's a massive irony. We are betting the wealth of a G7 nation on the idea that machines will become smarter than us. Yet right now, the danger is that our own organizations aren't smart enough to use them. As the white paper puts it, if this $3 trillion gamble fails, the fault line won't be in the silicon. It'll be in us. The ground is moving, so keep your eyes open. Thanks for listening to the AI Value Paradox. We'll see you next time.